Oh, okay. Hello. Um, these are two more questions for chapter 4, constrained motion, relative motion. 'Cause I actually forgot to do these in the last video. So, yeah. Okay, that's fine though. So, let's get started on these two questions. Cuz yeah, I didn't really go over these ones are good questions to go over because there's a lot of stuff in them. Consider the pulley system indicated below. Mass A is moving downward with an initial speed of VA equals 8 in meters per second and initial downward acceleration of AA equals 6 meters per second squared. Graphically establish the datum line and key path lengths from the datum lines, i.e. the position coordinates for this situation on the below figure. Clearly indicate the direction the mass B is moving with a vector labeled VB. Okay, I guess that stuff's already done. Because I don't have the blank of this question. So, anyways, the datum would be up here because, as you can see, this pulley here is connected to the roof. If you can imagine a roof up there, but this is connected, right? And the distance stuff is really easy. We have this is SC, SB, and SA. That's all pretty obvious. These velocities are already given. And using some logic, if you wanted to, you could like actually do all the calculations first and then put the direction of VB. But VB goes up because if this has to go down, then that means this mass has to go up. And then as you can see, and I'll change colors for this. There's one rope like this. And then there's a second rope like this. So we'll have two length equations, right? And okay, that's all that stuff. That's part A. So now we'll do part B. Determine the initial speed of mass B. So for rope 1, we're going to go L1. What do we have? We have SC, and then we have SB, and we have this length of rope here, which as you can see is SB minus SC. So this is equal to SB plus SB minus SC. And then we can just simplify this to 2SB minus SC, right? And now we need to look at rope 2, which has two SCs. And C is this pulley, by the way. And we always take the distance to the center of the pulley. Let me change the color here back to black. We always take the distance to the center of the pulley. So like SC goes to here. So we're kind of ignoring this bit of orange here. So we have two SCs and one SA, right? So L2 is equal to 2SC plus SA. And that's all there is to it, right? And we want to combine these equations somehow, right? So you could do it is if you double this and then add them together, that eliminates the SCs. So let's do that. We have 2L1 plus L2 is equal to 4SB plus SA. And we have 2SC minus 2SC. Like that. I keep clicking the wrong slash all the time. There. Yeah. This is what you'll get. So there's supposed to be a plus here. So these cancel, making them 0. And then you have this as your length equation. Now we're looking for initial speed. So we take the derivative. So 0 is equal to 4VB plus VA. We have VA. We want VB. So VA is 8. And then 8 divided. We're going to put minus VA to this side. Divide by 4. So 8 over 4, 2. So minus 2 meters per second is equal to VB. Which is the same thing as saying 2 meters per second up. Because we want speed, not speed, not velocity. Velocity would keep the negative, but this is speed. It's going up. This is the magnitude, so it's going up. And then for the next part, this is for, so let me just Q1, B, and then this is C. We want the initial acceleration. So we just take the derivative of this again. We have AA already. So we're going to have negative AA over 4 is equal to AB. And we're just going to plug in our values again. So that's going to be 6 over 4, negative 6 over 4, which is negative 1.5 meters per second squared is equal to AB, which is the same thing as 1.5 meters per second squared up. And that's that question. Very easy, very straightforward. And on to this one. Wait. On to this one. This is Q2. At the instant shown in the picture to the right, car A is traveling at a speed of 90 kilometers an hour and car B is traveling at a speed of 65 kilometers an hour. Assuming I hat points in the direction car A is moving to the right and J hat points up, car B is increasing his speed by 2,000 kilometers per hour squared, while car A maintains a constant speed. Car B moves along a curve, having a radius of curvature of 800 meters. Specify all units using kilometers and hours, all directions in the IJ plane, and all angles measured in degrees counterclockwise from I. Okay, so first of all, we need to we have VA, we have VB, we have an angle. We know that I points in the direction car B is moving. In the direction car A is moving, sorry. So let's quickly draw out our positive plane like this. I and J, right? So that's that. We know that VA is 90 kilometers per hour. I and VB, we need to split into components. So VB is equal to, it's X and Y, or it's I and J components. So 65. For I, it's going to be cosine 30. I'll put an I here. Plus, for J, it's going to be 65 sine 30 J, which is just sine 30 is a half. So if we calculate these numbers, let me get my calculator. 65 cosine 30 is 56.3, 56.3 I plus 65 over 2 is 32.5. I could have done that in my head. I didn't need a calculator. Whatever. 32.5 kilometers per hour J. Okay, so we have VB, we have VA. We want, and this is a relative motion, or let me just move this over to the side a little so that this pencil thing doesn't block it. We want the velocity and speed of car B with respect to car A. So B with respect to A. So that's relative motion. And we know that V of BA is equal to VB minus VA. So VA is 90 kilometers I. So we're just going to have 56.3 minus 90. And then 0 minus 32.5. So VBA is equal to, let's see, 56.3 minus 90, which is negative 33.7 I minus 32.5 J. Or I mean, not minus. Sorry, this is plus, because this is not on car A. This is on car B. So yeah, that is VBA. And the speed is just the magnitude. So we're going to take the magnitude of VBA. Magnitude of VBA. Which is equal to the square root of 33.7 squared plus 32.5 squared, which is equal to, let's see, square root of this squared plus 32.5 squared is 46.8. 46.8 kilometers per hour. And that is part A of the question. Let me just label that quickly. Part A of the question. And now on to part B. So at this instant, determine the angle that car B is moving relative to car A. So it wants the angle of VBA. And we have an I component and a J component for VBA, which means we have an opposite and an adjacent. So that's just tan theta. Wow, that's not how you spell theta. Tan theta equals, what is it? 32 opposite over adjacent. 32.5 over negative 33.7. So that means that theta is equal to the inverse tan. So arctan, because writing inverse tan is boring, of this. That's going to make it a hyperlink, so I don't want that. 32.5 over negative 33.7, which gives us a theta of, let's see, arctan of 32.5 over negative 33.7, which is negative 44.0 degrees, right? But we want it to be in the, we have a negative I and a positive J. So what does that mean? Negative I, positive J, we're in this quadrant, right? And we just got an angle that's relative to the x-axis of negative 44. So how do we go from here to here at 180 degrees, right? Like we have this angle that's like this, and we need our angle to be up here. So from the positive x-axis, or the positive y-axis in this case. So at 180 degrees. So plus 180 degrees gives us 136 degrees. Very nice. Part C, at this instant, determine the acceleration of car B with respect to A. So we'll be using the same things, right? Where yeah. So A of B, we need to split up into its components, which is we need the derivative of VB, which we know that car B is increasing its speed by 2,000 kilometers per hour in its tangential direction. So that is our AT. So 2,000 I, right? Or we need to make it into I and J. This is not in I. Sorry, 2,000 cosine 30 I plus 2,000 sine 30 J, right? And then if we just calculate that quickly, 2,000 cosine 30 is 1732. So AB is equal to 1732 I plus 1,000 J. Okay, that is very easy. That is its tangential acceleration, ABT, because remember the 2,000 is its tangential. We also need the normal, it's curved. We have a radius of curvature of 800. So ABN, we need to also split into I and J components. We have radius of convergence of 800, and we know that it's going to be this much plus here, this angle plus here to get to the I. So we can flip our I and J thing by like 30 degrees, and then we'd have to just fix that again anyways. So yeah. Sorry, I blanked for a moment there. So we're adding this for the I, like the tangential and normal thing is here like that. So that means the normal is over here. So it's 90 is like this plus 30. So it's at an angle of 120 degrees for the normal of car B. So all of our trig terms are going to be 120 degrees. So we know that the normal is velocity squared over rho. So we're going to have 65 squared over rho of 800, like this. And this term is going to repeat, so I'll just copy and paste that. And then the first one is for the I, it's going to be cosine of 120. So cosine, cos 120. And then this is plus this sine 120. So we get an ABN, which is equal to, let me just quickly calculate that, 65 squared over 800 cosine 120 is negative. Oh wait, sorry, this is in meters. This is supposed to be 0.800. 0.800. So we'll just times this by 1,000 quickly. Negative 2641. Negative 2641 I. And also I should be attaching I and J to these. I. And then let's see, the second one is 65 squared over 0.8 times sine 120, which is plus 4574. Plus 4574J. Okay, so we have AN and ABN. And we want to get AB. So AB is just the difference between, or I mean, it's AB is the addition of its components in the I and J coordinate system. So the IJ plane. So that means AB is just equal to ABT plus ABN. This is in component form. So like do this normally, you would you'd square everything, right? But that's okay this time because we don't need to do that. So adding up all these terms gives you AB equals, so in the I we're going to have 1732 minus 2641, which is negative 909 I. And then we're going to have 1,000 plus 4574, 5574J, just like that. Okay, and now we can finally get our ABA, which is equal to AB minus AA. We have AA. Oh yeah, AA is straight this way. Constant speed. AA is not actually anything. There is no AA because constant speed means there's no acceleration. So AA is 0. So we can remove this term and say that ABA is equal to AB. So ABA is equal to this. I'm just going to, there's supposed to be a plus here. ABA is equal to this. So I'm just going to put this down here. And we also, and that's it. At this instant, determine the acceleration of car B with respect to car A. If you want to get the magnitude, you can do that as well. It's not needed because it doesn't ask for the magnitude. It asks for just the acceleration. And then finally, at this instant, what angle is car B accelerating relative to car A? So this is C. Wait, A, B, C. Or this was C here. Oops, I forgot to put a C here. C, this is D, right? We want the angle, so we're just going to go back to our tan theta thing. Tan theta is equal to, we have, again, opposite over adjacent. So 5574 over negative 909. So theta equals arctan of this. Theta equals arctan of this, which is equal to negative 80.7 degrees. Oops, degrees. But again, this is this situation again. We're in quadrant 2, but our angle is in quadrant 4, right? So add 180 plus 180 degrees is equal to 99.3 degrees. And that is it. These were supposed to be in the last video. I just kind of forgot to I forgot to do them. That's all. 2 easy questions, but yeah, thank you for watching. I hope this is a good learning thing. Bye.